Okay, here's my audience. My speech will begin now. What if I told you that everything we know, our whole universe, lies within a net known as the gravitational field? And within this net, we are able to observe gravity in the form of gravitational waves. Now, gravity is more than something that holds us down to our own planet. The first prediction of gravitational waves was made in 1915 by Albert Einstein with his theory of relativity. This theory governs the laws of physics. It states that space and time are warped by mass and energy, and this warp in space and time controls the motion of light, stars, etc. Now, at the time of his prediction, there was no technology great enough for him to prove his prediction to be true until more recently. On September 14, 2015, the first detection of gravitational waves was made by LIGO, the Laser Interferometer Gravitational Wave Observatories, located in Livingston, Louisiana, and Hanford, Washington. Physicists proved that these gravitational waves came from the collision of two black holes that created one larger spinning black hole. Now we look into the beginnings of understanding space and time and how gravitational waves were predicted and later proven to be true as a true phenomenon. Now, with Einstein's theory of relativity, it states that space and time are characteristics of a measurable reality known as the space-time continuum. And within this space-time continuum, the presence of large masses or energy distorts the space-time, causing a warp that we observe to be gravity. So if you were to look at this as if it were a memory foam mattress and you placed a weight on it, and that weight being anything that has mass, such as a planet, a star, a black hole, you'll notice that it'll create a dent or a warp in the mattress from the flat line, and this is what we observe to be that mass's gravity. Now, the presence of large mass and energy that distorts this, such as black holes orbiting one another, releases energy in the form of gravitational waves. And as they do so, they gradually orbit towards each other until at the last few moments it speeds up until they collide. Now, this collision combines the masses of the two black holes into energy in the formula known as E equals mc squared, which is Einstein's formula. So when dense objects such as black holes orbit each other, it creates a binary system, and this creates energy from the motion throughout the space-time continuum, creating ripples. Now, black holes do not give off light, so they cannot be seen, so instead they make noise in the form of gravitational waves. LIGO detects these waves by their interferometer devices. Now, how does it do this? You can think of LIGO, both in Livingston, Louisiana, and Hanford, Washington, to be identical in an L-shaped formation, both running about 4 meters long in both directions, and at the end of each is a photodetector that detects the amount of light captured by a laser that meets at the middle. Now, anything that disturbs this laser light will create gaps in time that is detected by the photodetector. So, for example, when a gravitational wave passes through the interferometer device, the disturbance that it makes within the laser light is detected by the photodetector, which converts it from gravitational waves into electrical signals that we are able to see and hear and observe. So on September 14th, 2015, when the first gravitational waves were caught by LIGO, it was a huge moment in science. The gravitational waves were first captured about 7.3 milliseconds in Livingston, Louisiana, before the ones in Hanford, Washington. This allowed them to predict that the origin of the gravitational waves came from the southern hemisphere. So this goes back to proving that gravitational waves can give their origin of where they came from. The physicists were able to predict that the gravitational waves were caused by the conversion of two black holes coming together, both being 29 and 36 times the mass of the sun. and the energy produced by the collision was 3 times the mass of the sun. They also predicted that this collision happened about 1.3 billion years ago. So in order for LIGO to detect gravitational waves to be true, there has to be at least 2 of these interferometer devices between a large period of space, and the gravitational waves detected have to be equal or greater to the mass of the sun. So now you may be wondering, why should you care about these gravitational waves? Well, with this new found of gravitational waves, we are able to make new discoveries in science about our universe, and hopefully later on, more scientists around the world, hopefully later on in the future, we will be able to put up more interferometer devices, maybe even with greater technology, so scientists are able to better pinpoint and more precisely study gravitational waves and their origin. So in conclusion, the detection of gravitational waves by LIGO helps us to learn about how mass and energy interact with space and time. With this theory that was derived by Albert Einstein almost 100 years ago to date, of when we were able to predict gravitational waves, and with our ever-growing technology and our growing knowledge, we are on the right track to make leaps and bounds in the world of science.